What's up everyone, welcome to Indomitable Tech. This is your AIML consultant Shaunak, and in this particular video we'll be focusing on anomaly detection on multivariate dataset. So if you want to refer to this particular notebook, I'll be providing link in the description. This notebook will be hosted on GitHub. The dataset that we'll be looking at is this thyroid disease unsupervised anomaly detection dataset. Link is mentioned in the first code block of the notebook, and this is for multivariate. If you want to check for univariate data, we have two other videos for those, one focusing on statistical methods to detect anomaly and another one focusing on machine learning models. Now let's jump into it. If you want to see the details, it is on Kaggle, the details of the dataset, what all columns are categorical, what all columns are numerical, and this is how the dataset is appearing. In total there are 23 columns. So let us, first step, we will be importing library. Second step will be reading the dataset, then we will be pre-processing the dataset, and then finally we'll be building the model. So let's do that. So let us import pandas to read the data frame. Import pandas as PD, then we will use sklearn. So from sklearn dot, we won't be making use of normalization since we are already standardizing. So sklearn for standardizing numerical data. From sklearn dot pre-processing import standard scalar. Then we'll be importing isolationforest from ensemble, oneclasssvm from svm, and kernel density from neighbor. So from sklearn dot ensemble import isolationforest, from sklearn dot one svm import oneclasssvm, then from sklearn dot neighbors import kernel density. Then classification report, it is a metric that we'll be using to check the performance of our models. So from sklearn dot metrics import 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 classification report, and then we'll be making use of quantile. Quantile we will be using only for kernel density. We have to calculate threshold when we are working with kernel density. So to calculate the value of that threshold, we'll be making use of this quantile. I'll explain this when we are discussing kernel density. From numpy import kernel, sorry, not kernel version, import quantile, execute it, done. So CSV path to the dataset is this on my local system. It is in this folder dataset. So I'll create the data frame. So raw df equal to pd dot read underscore csv and csv path, and the separator that we'll be using for this particular dataset is this semicolon, because the columns are separated with this semicolon. If you open this CSV file, execute it if you want to see how it is appearing. Raw df dot head, let's see the first three rows, and it is appearing like this, age, sex, and other columns. This unnamed 22 and unnamed 23, so these are the redundant columns. Maybe these two columns got read by mistake when we are reading. So let us remove these two columns, and this outlier label is the target column, which we are not going to consider when we are building our model. So let us get rid of these two. And also, if you see, some columns are in lowercase and some are in title case, like this T3 measured, this TSH is in all uppercase. So what we'll do, we'll convert all these columns into lowercase format. So let us first process the data, remove the unwanted column. So let us remove this unnamed 22 and unnamed 23. So raw df dot drop, and since the columns that we are going to remove is more than one, we have to pass a list. list of these two columns, and then x is equal to 1, and then in place equal to true, true. Then let's remove duplicate columns. So raw df dot drop duplicates, in place equal to true. Execute. Then check for missing values. I'll remove these blank code blocks that we are not going to use. Then check for missing values. So raw df dot isNA dot sum, that will give us the sum of missing values for every column. So since everything is 0, there aren't any missing values. Now let us convert the column names to lowercase format. So raw df dot columns gives the list of the columns. So for every item in the list, we'll iterate using list comprehension, and since it is in string format, we will use string dot lower method. So equal to list comprehension item dot okay, so I am going to use strip as well, because there can be some cases where white space, that is space, is before or after the column name. So just to be safe, I'll use strip dot lower for item in raw df dot columns and execute it. Now that's done. If you want to see the name of the columns, all are in lowercase format now. Now create feature and target data frames. So target name equal to, so let me quickly execute the let me first execute columns, so we come to know what all columns we have. This outlier label is the target name, so that we will be removing from the list. And feature names, since it is more than one, I'll put it in list comprehension. So call name for call name in raw df underscore columns, sorry, raw df dot columns, if call name is not equal to target. So all the columns we will be considering except for this outlier label. Now that is done. Then let us create the data frames. Features equal to raw df, and here we will be considering only these columns, and dot copy, so it will create a copy based upon this data frame, sorry, based upon this data frame raw df. And similarly features we have, then target raw df and target name. So this will create a series. So if you have multiple columns, then it is a data frame. If you have only one column, and if it is in vector format, then it is called as series, panda series. So dot copy. Upon executing, okay, feature names, it should be, not features. Okay, and now if you want to see features, or first 3 rows, we have all this. So these are the features. And if you want to see how target is appearing, it is a series. So when you are going to work with isolation forest or one class SVM, after the model is built and after the model makes predictions, it will predict anomalies as -1 and normal values as 1. So what I am going to do is substitute -1 for this O. So O is outlier, so I'll substitute O by -1 and N by +1. So target dot map lambda label -1 if label equal to O, else 1, and I'll save this to target. And now if you see target, it is in terms of -1 and +1. So now that's done. So let us check for impurity. Impurity is nothing but the percentage of outlier in your existing data. So let us quickly do that. So target, first let me calculate the ratio value counts. So 250 outliers and there are 6595 normal values. So let us calculate impurity, that is the proportion of outlier. So it is 250 divided by 250 plus 6595. So that's the impurity. And why I am calculating this impurity is because in isolation forest we have a parameter that we are feeding while building the model. The parameter's name is contamination. So that contamination we have to pass in the impurity value over there. For one class we have similar such parameter by the name of new. So that new will be the impurity. And while calculating the threshold, we have to in kernel density, while calculating the threshold, we have to give the quantile value. So that quantile value will be our impurity. So it will calculate that threshold at that particular quantile. So that quantile is will be our impurity. So that's the reason I have calculated the impurity, the ratio. In if we don't have such a target column, then we have to calculate such impurity based upon case to case basis. And if you have an expert who has worked with such items, or if he has that the domain knowledge of how much values will be the outliers or anomalies, then that person will be able to give this impurity. If not, since it is a hyperparameter, you can train and evaluate the model, and based upon that you can select the impurity which gives the best result for that particular data set. So moving ahead, so on reading the database, we come to know that these are the categorical columns and these are the numeric columns. So the reason why I am mentioning it is because when you are standardizing or normalizing the data, so standardizing and normalizing needs to be done on numeric columns and not on categorical. Categorical columns will remain in terms of their particular labels, and if the labels are in text format, then you have to convert it to numeric format, that is either 0, 1, 2, but it should not be in continuous format, it will be in categorical format. So let's proceed. Since categorical columns are already in terms of numbers itself, we won't be using one hot encoding or cat calls. So basically we won't be converting the string to numeric format for categorical columns, but we will be using scaling, standard scaling on numerical columns. So from categorical and numerical columns, so let me create a list of categorical and numerical columns. So categorical columns equal to, I'll just copy this and numerical columns. So this standardization that will help us to process build the model faster, the training is faster, and also computer finds it easier to calculate based upon the standardized value. And we won't be looking at normalization for this particular scenario. So let us scale and standardize the numerical columns, sorry, my bad. So scalar, let me create the scaling object, standard scalar, and then features, let me execute this, I forgot to execute numerical column because we'll be applying this standardization only to the numerical columns. Scalar dot fit transform, on that numerical columns. That's it. And now that we are done with standardization, now let us proceed on to build the model. One more thing, let me quickly check the data types just to ensure the categorical columns are appearing as category. So features dot info. Okay, so all are appearing as float, even the categorical columns. So what I will do is quickly convert the categorical column data types to category. So let me just comment over here, checking the data types of columns, and one more code block, convert categorical column data types to category. So I'll iterate over the numerical columns not numerical columns, I'll iterate over the categorical columns, since we are going to convert the categorical column data types to category. For column in categorical column, feature column equal to features column dot as type, and here I will pass it as category. Now that is done. If I see this again, features dot info, you will see all the categorical columns data types appearing as category. So this is important because it will tell the model that this particular column is a category and not a numerical column. So treat it as a category when you are building the model. Now let us build the model. First one is isolation forest. The name of this model, I will save it in this variable if for isolation forest. So isolation forest, and the parameter that will be passing over here is number of estimators. Let's keep it to 300, and contamination will be the impurity that we calculated. Then let us fit features, if dot fit features, and then let us predict. So we will save that in if underscore pred equal to if dot predict, and we will feed it the features, and the output we will be comparing it with the target column. So this if underscore pred will hold the predicted values. That's all for isolation forest. Similarly, we are going to do for one class svm. So let us save it as OC for one class equal to one class svm, and here you have to pass in the value new as impurity, and then OC dot fit, again features, since we are training on features, and then OC underscore predict equal to OC dot predict, and again features, because we are going to use the model to predict whether the given rows are anomaly or not for features. So OC underscore predict will have the predicted values for one class svm. Now moving on to kernel density, kd equal to kernel density, and then we will do kd dot fit features. So this will train the kernel density model, and now to calculate the threshold we will calculate the scores. So kd dot sample scores, score samples, and here we have to pass features. So it will predict the features, it will predict the scores for every row in features, and we have to now select the threshold equal to quantile. This quantile we imported from numpy at the very beginning, this quantile. So we'll be taking the quantile which is at the value impurity. So quantile scores and impurity. So at this quantile, what is the value? That value will be the threshold. Now let us create a list for KD predictions, KD underscore pred equal to, that will be a list comprehension. So -1 if instead of value I'll call it score. So we are going to loop over this score, and whatever value is less than this threshold, that will be the anomaly. So anomaly, we are -1, we are designating -1 as anomaly and 1 as normal. So -1 if score is less than threshold, else 1 for score in scores. So KD underscore prediction will have the prediction for kernel density for features, every row of features. So -1 will be for anomaly and 1 will be for normal. Now I'll execute it. So it is still processing, let's wait. Okay, now it is done processing, and the target that we converted, yeah, -1 and 1. So we'll be converting the predictions against this column. So if underscore pred and target, this will be for isolation forest. Then for one class it will be OC underscore pred and target, and for kernel density equal to KD underscore pred and target. Now let us execute it. So if you see, for isolation forest, accuracy is more than 90, but don't consider accuracy in such cases, because even if it predicts, most of the times, since this is a anomaly detection, we are going to focus more on F1 score. So for isolation forest, the F1 score for anomaly is 0.06, for one class it is 0.17, and for kernel density it is 0.22. So out of these three models, for this given data set, we are going to be considering kernel density, as it gives a better F1 score. So here that's the reason I have mentioned kernel density gives the best outlier estimates. So out of these three, kernel density model is better. So that's all for this particular video. Just to recap quickly, I'll go through the entire notebook. What we did was, we first imported the necessary libraries, pandas for reading the data frame, then sklearn for pre-processing the data and building our models, and also for using the metrics, that metrics tells us the performance of our models. Then what we have done is, we have read the data set into a pandas data frame, then we have pre-processed the data set and use standardization to standardize the data set. Then we have built three models, and then we have fitted the pre-processed data frame to these three models, and based upon these models, then we have predicted the anomalies, and we have then compared those anomalies with the existing target column, and based upon that we are able to see which model is performing better based upon the F1 score. So that's all for this particular video. This particular video is part of a playlist for machine learning for beginners. If you have any queries, you can write in the comments, or you can also write me on my email. The email, I'll be mentioning it over here at the bottom. Okay, by mistake, instead of adding edit, undo, delete set, instead of adding, I deleted a code block. So here I'll be adding my email ID, name, and email, shaunak.python@gmail.com. So if you wish to collaborate, or if you want to get in touch with me, you have my email. So that's all for this video. I'll see you in the next one. Bye.